Okay, so today we are going to talk about number 25. Number 25. Okay, let's see what we got here. So the function g is defined on the differentiable the function g is defined and differentiable on the closed interval from -7 to 5 and satisfies g of 0 equals 5. So this is, as always, I'm going to kind of just make a note that this thing passes through the point 0, 5. The function g, not the graph. So maybe I should just put this off to the side over here. But I know that g passes through the point 0, 5. That's always some sort of initial condition. That's always nice to know. The graph y equals g prime of x, the derivative consists of all that stuff, is shown above. So this right here is a derivative function, right? So this right here, as we can note, is the function g prime. Okay, let's see what we can do. First, find g of 3, then g of -2. Okay, so in order to find g of 3, I'm going to have to start with something I know. So in other words, I know what g of 0 is, they told us. So what I'm going to say is it equals g of 0 plus the displacement from 0 to 3 of g prime of x dx. Okay, so from there, I'm just going to be calculating those values out, but hopefully that makes sense. Again, you always start with what you know, and then you add the displacement. So let's see what we got here. So g of 0, we were told, is 5. And then what I have to do is, looking at the graph, right? I'm going to have to go to g of 0. So in other words, I'm going to go and find the area from here all the way to there. So let's do that. So that is, first part is a quarter circle. So that is 1/4 pi r squared, where r is 2. So 2 squared. And then the other part is a triangle. So 1/2. The base is 1. The height is 3. Okay, now that's a number. We can keep it like that if we want to. If you want to simplify it, you're going to get 13/2 plus pi. Okay, that's g of 3. Let's go find g of -2. So g of -2, I'm going to do the same thing. Exact same thing, really, right? I'm going to say it equals g of 0 plus the displacement from 0 to -2 of g prime of x dx. Now we have to be careful, right? Because this is going from 0 to -2 instead of -2 to 0, which is the way I want it. So I'm going to use the property where I can flip the limits of integration, right? So now they're going to go from -2 to 2, but -2 to 0. But in order to do that, right, I've got to change my sign. So it was positive, now it is negative. Okay, so what does that equal? Well, we already know that g of 0 is 5, and now we're going to be subtracting, let's kind of get rid of this stuff, we're going to be subtracting this quarter circle right here, which we already found the value of, right? We already know what that quarter circle's area is, just pi. So we get 5 minus pi. Let's move on. Letter B. So find the x-coordinate of each point of inflection for the graph y equals g of x on its interval. Okay, so we want to find inflection points. So remember, inflection points occur, we're looking at the second derivative, right? So what do we have to do in order to do that? Well, I have to look at where the first derivative changes from increasing to decreasing or decreasing to increasing. So let's go along and see. So I'm just going to kind of, just to exaggerate this a little bit in case it's been a little while for some of you, let's see what's going on. So as I'm going, my function right here, the slopes are positive, right? So the function is increasing, 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 increasing. Oh, now it's going to go to decreasing. So at x equals 0, right, it went from increasing to decreasing. So there has to be a inflection point right there. Let's keep on going. So now, as we can see, it was decreasing, 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 but At x equals 2, now it goes back to increasing, increasing, increasing. So we know that there is an inflection point here. And then finally, right, as we can see, it went from increasing, increasing, but then at 3, it went back down. So there is another inflection point right here. Okay, so we have 3 inflection points, one at 0, one at 2, one at 3. So let's do it. So I'm going to say, actually, I'm going to type this. So there are 3 points of inflection. So at x, I'm going to just to keep things short, I'm going to talk about x equals 0 and x equals 3 because both of those change from increasing to decreasing, and then I'll talk about x equals 2. So at x equals 0 and x equals 3, there are inflection points because g prime changes from increasing to decreasing. At x equals 2, there is an inflection point because g prime changes from decreasing to increasing. Okay, before I leave that alone, let's just make sure that we are good. On the increasing, decreasing, instead of using positive, negative. Now remember, the reason I'm using the words increasing or decreasing is those represent derivatives. And when I'm looking at this graph, I can't just say this goes from positive to negative. I'm talking about the slopes of these tangent lines, and slopes are derivatives. So by using the words increasing and decreasing, I'm saying I'm looking at the graph and I'm taking its derivative. Okay, I'm looking at those slopes of those tangent lines. So I'm taking its derivative. So I have to use those words increasing and decreasing. Okay, and that was letter B. Let's move on. Letter C. I'm going to move that down. What do we got here? Okay, I'm going to move this down here so I have plenty of, whoops. That worked super well. I wonder why it didn't let me grab it. Let me try one more time. If it doesn't, I'm going to grab the whole thing because maybe that's the problem. Yep. Okay, let's grab the whole thing. Whoops. I'm just causing all sorts of problems here. Oh, okay. Actually, I'm going to just do this really quickly. I'm trying to, it seems to be having a little bit of issues in the grabbing, but this should work just fine. Okay. Sorry for the delay. But as you can see, there were technical issues. Okay, what do we got for C? The function h is defined by this stuff. Find the x-coordinate of each critical point on -7 to 5, and then determine if it's a minimum, maximum, or neither. Okay, so we are given that h of x equals g of x minus 1/2 x squared. I want to go find the critical point. So what do I always do in order to find critical points? I take the derivative. So I say h prime of x equals the derivative of this, which is g prime of x, minus, well, the derivative of that is just going to be x. And then in order to find critical points, we set the derivative equal to 0. So I'm going to set h prime equal to 0. And I have to solve this equation. And I think you would agree this is going to be equal to g prime of x equals x. So I want to, in order to find the critical points, I want to know where g prime of x equals x. So let's go to our graph. So let's take a line, let's graph the line y equals x, right? So the line y equals x is going to look like this. So anything, any time or any value of x for any value where these two graphs cross, the red and black, right? We have critical numbers. So we have a critical number here, whatever that is, and we have a critical number at 3, 3. Okay? So let's go and first off, let's go and find this critical number. So in order to find that critical number, right? So in this case, I think you'd agree this is a semicircle right here. This is all part of a circle. So with a radius of 2. So in other words, if I were to say, okay, well, that's a circle, so x squared, whoops, let's do this in blue. If I wanted to find the equation of that circle, I think you'd agree, it's going to be x squared plus y squared equals 2 squared or 4. So y squared, actually, doing some solving, I get y equals plus or minus. I'm not going to, obviously the plus or minus doesn't matter, 4 minus x squared. Okay, so in other words, this function right here, let me highlight, this function right here is represented by that, the positive root of that. So what I want to know is I want to know where does that equal x. So I'm going to say x equals this stuff because I want to try to find, right? I'm trying to find where does the black part intercept the red part. So I set them equal to each other, squaring both sides. I get x squared equals 4 minus x squared. So 2x squared equals 4. X equals plus or minus root 2, but I'm going to give myself plus root 2, and the reason is I'm not looking at the negative side, I'm just looking at the positive side. Okay, so we have two critical values, one at x equals 2, and the other critical number is going to be at x equals 3. So let's sum that up. I'm probably going to have to do this a couple times. So, boop. There are two critical numbers. There are two critical values. One at x equals, what was that, root 2? Okay, so this is where I should have probably printed this. One at x equals root 2, and the other at x equals 3. Okay, so now we need to determine, we've determined what those critical values are, but now we got to determine, are they minimum, maximums, whatever. So let's look at our graph. Let's go back to our graph. So, and let's just kind of erase some of this stuff here. So let's start with, I'm going to make a quick little sign chart up here. Since it's not really part of the problem, my answer, I can make a sign chart. So we have our two critical numbers. One's at root 2 and one's at 3. So let's look at root 2. Now, if I choose values for x that are less than root 2, right? So if I choose, for example, this value right here, x equals 1, I think you'd agree that the black curve is above the red line. In other words, if you were to, and I'm gonna probably end up showing this, if you were to say, if h prime of x equals g prime of x minus x, right? Well, g prime of x minus x, right? If you take this curve minus this curve, you're going to get a positive number. So that's going to be positive. To the right of that, so right, any point in here, the black curve is below the red line, so it's going to be negative. Okay, now also notice that from there on out, everything's below the red line, so everything's going to be negative. So what do we have? We have a maximum here and probably some sort of stall there. So let's put that together. So I found my two values, so I'm going to say at x equals root 2 there is a maximum. Whoa, there is, why did that happen? Boy, and it's not happy now, I think. This thing just crashed. Oh, let's hope that we are okay. I think I am. I'm gonna just close this down real quickly and then I'll come back to it. Should be fine though. Yeah, okay. So x equals root 2, there is a maximum. And how do I know? Well, I know it because, I probably should say that, because h prime of x, which equals, right, g prime of x minus x is greater than 0, is greater than 0 when x is less than root 2 and h prime of x, I'm not going to rewrite that whole thing, I've already kind of said, h prime of x is greater, well, maybe I will, which equals g prime of x minus x is less than 0 when x is greater than root 2. So I've established it as a maximum, and then I'm going to say at x equals 3, there is a critical value. There is a critical number, but it is neither a minimum or maximum because h prime of x never changes sign. Okay, and I think that is it. That's all there is to it. So anyway, hopefully that was useful to you, and I'll see you on the next problem.